Unit 2, Properties of Matter. There are two major properties that we use to describe matter: physical properties and chemical properties. Physical properties are properties that can be observed without changing the composition or the makeup of the substance. Physical properties include things like appearance, texture, odor, boiling point, melting point, density. Chemical properties are the properties that allow matter to combine with or change into different types or new substances. It's very difficult to describe a chemical property without using the term change. So, if we consider a green polo, upon closer inspection we can see that it's green. We haven't changed the makeup of the shirt. It's still a shirt. It's still made of cotton or whatever. Color is a physical property. If we were to place your polo onto a scale, we could find out that its mass is 122 grams. We haven't changed the composition, therefore mass is a physical property. But what if we decided to test the flammability of the shirt? Well, by putting the shirt into the fire, we would change the composition. It would no longer be a polo, it would be a pile of ash. It's a new substance. So flammability would be considered a chemical property. Let's look at some properties of copper. If we said that copper forms a deep blue solution when in contact with ammonia, would that be a physical or a chemical property? What if we said that copper was reddish brown and shiny? That it's a good conductor of heat and electricity. What if we said that copper would form a new compound when combined with nitric acid and sulfuric acid? Would knowing that copper forms a green copper carbonate compound when in contact with moist air, would that be a physical or a chemical property? What if it was easily shaped into sheets and drawn into wires? If we said that the density is 8.92 grams per cubic centimeter? Copper melts at 1085 degrees Celsius. Or copper boils at 2570 degrees Celsius. If you picked all of the three on the right, you'd be right that those would be our chemical properties, and the ones on our left are our physical properties. Notice in each of our chemical properties we see the key term forms. So something new is made. The state of matter is a physical property. There are three common states of matter. The first would be a solid. Notice how the solid particles are all densely packed together. There's very little space in between. These molecules. We say that solids have a definite shape and a definite volume. Why do we say that it's definite? Because it doesn't matter on its location. This cube of molecules, it doesn't matter where it is. It's still going to be a cube. Liquids, on the other hand, if you'd notice, are more spread out. Look at this room that exists in between liquids, in between liquid molecules. And notice we also need a container to hold these. The reason that we do is that these liquid molecules have weaker intermolecular forces. These weaker intermolecular forces allow them to have a variable shape, but a definite volume. You can't pour 2 liters of soda into a cup that doesn't hold 2 liters. So, what phase of matter is this solid block of ice? Well, it's solid. If we moved the ice from outside of the glass inside the glass, did its shape change? Does its volume? The answer to both of these are no, because the shape and volume of a solid are both definite. But let's consider liquids. These liquid molecules inside the beaker have a cylinder shape. But if we pour that cylinder, if we pour that beaker into a flask, well, the shape of the molecule changes. We now have a triangle shape. We still have the same number of molecules. We have the same amount. They're taking up the same amount of space. It's just a different shape. This is why we would say liquids would have a variable shape, but a definite volume. The third state of matter is gases. Gases have the weakest of the intermolecular forces. And they're the most spread out. Look at this distance. Look at how spread out these gas molecules are. Now, we can change the shape of these gas molecules. Probably the most common example would be the making of balloon animals. Blow air into a balloon, and then you can shape it any way you want. But we can also change the volume. Because there's all this room, all this space in between molecules, we can compress it down. One of the most common examples would be a tank of helium. This tank of helium contains approximately half of a cubic meter of helium. That's much more than the actual volume of the container itself. As we're talking about matter, there are two major types of matter. There's substances and there's mixtures. A substance is matter that has a uniform composition. It means that it's always the same, it's unchanging. Examples include things like water. Water is always made up of 2 hydrogen atoms and 1 oxygen atom. Table salt. It's always made up of 1 chlorine atom and 1 sodium atom. We can even take those things themselves, things like chlorine atoms. Chlorine atoms constantly have the same number of protons, the same number of electrons. It's uniform, it's unchanging. Mixtures, on the other hand, are a combination of substances. They're made up of 2 or more things mixed together. Each substance retains its individual properties. The composition of mixtures can vary. And there are different types. There are 2 major types of mixtures. We'll talk more about mixtures in a little bit. So matter can either be a pure substance or a mixture. And the 2 types of pure substances are either element or compound. Elements are substances that cannot be broken down into simpler substances. Elements contain only 1 type of atom. For example, things like aluminum foil, carbon, oxygen. These things only made up of 1 type of atom. Compounds, on the other hand, are substances that are made up of 2 or more elements, and we can break them down into simpler substances. Compounds can be broken back down into the elements that make them up. When we have a compound, the properties of the compound differ from the properties of the substances that make them up. And compounds always contain 2 or more elements that are joined in a fixed proportion. For example, H2O. There's always that 2-to-1 ratio. So let's think about water. That's right, Homer. Water is a compound that's made up of 2 different elements. It's made up of 2 hydrogen atoms and 1 oxygen atom. So what is a physical property of hydrogen and oxygen? Right, they're both gases. But when we take those two gases, when they combine, they form water, which is a liquid. So we see the properties of a compound differ from the properties of the elements that make them up. Let's look at another example. Chlorine gas. Slightly greenish in color, and actually very poisonous. In fact, during World War I, chlorine gas would be put into shells and shot at opposing soldiers. This led to the necessity of having a gas mask. If our soldiers weren't wearing gas masks and a chlorine shell exploded near them, well, they could die. Now, sodium reacts very interestingly with water. So, elemental sodium will react violently with water. It will cause an explosion. Chlorine gas will kill. But we combine them together and we get salt. Relatively safe in small amounts. So the properties of the elements differ, or the properties of a compound differ from the properties of the elements that make them up. So we have our two different types of pure substances, elements and compounds. Now let's look at the two different types of mixtures. These are homogeneous and heterogeneous. Homogeneous mixtures, or heterogeneous mixtures, the parts of the mixture don't blend together. They have noticeably different parts. That's because the prefix hetero means different. Each individual particle remains distinct. So if we were to mix sand with water, we can noticeably tell the difference between the sand and the water. Pepperoni pizza, well, there's pepperoni, there's cheese, there's the crust that makes it up. So we can point out the different parts. And as we can see, the trail mix, we can notice the difference in the different kinds of nuts that go in to make it up. These are all mixtures. All of these particles still retain their own chemical properties. Mixtures are key because the composition can vary. If we go back and think about our pepperoni pizza down here, okay, we can make a pizza with more or less or no pepperoni at all. We can use more cheese or less cheese to our liking. The ability to change the amount of substances that go into a mixture is a characteristic of mixtures. Homogeneous mixtures, on the other hand, have a constant composition throughout, which means that we can't tell the difference in their parts. So when we look at a penny is an alloy. It's a mixture of different types of metals. We have copper as one of them, and zinc is another alloy. Zinc is another metal that goes to make up that alloy. Okay. When milk is a mixture of things like protein, fat, sugar, but we can't tell the difference. We can't say that there's the little bit of fat, there's the little bit of sugar.